You're going to say if someone's wrong, ne? Okay, next one. Tsepo? You have to do your own one, not look at Nintendo's. Nintendo? On the dot. Is it on the dot? Yes. All right. And then Kitlano? 36.4. All right. Then when you add all of them together, what do you get, Rita Vile? 6,539.82. Okay. So that is your total mass of all of the isotopes together. Now, if you add these percentages together, they should give you 100. Okay, so you're going to take your total mass and you're going to divide it by 100. So you're going to say 6539.82 divided by 100. Now, let's say it's a big question like this. This part here will count 2 marks. Okay. Then the fact that you divide by 100 will count a mark. So even if you make a mistake here, but you still show me that you divide by 100, you get that mark. Okay, so don't skip that part. You need to show that. Yes.
If like you complete the answer on the computer, then like you don't like that wrong. That is that answer, and you don't like those answers on the side.
Well, you need to show me somewhere that you multiply them together. So you don't have to write me that. You have to show me that you multiply them together. If you show me that, you get your marks. Do you do it on a fraction?
No, like on my computer.
Okay, but you need to show that part. Okay. All right, and then you divide by 100 and you get that answer so many units. Eh? Because it's 65.3982 blah blah blah, and if you round that off you get 40. Final answer, you round off to 2 decimals. But you don't have to, but it's good if you practice. Yes.
If my answer is 65,395.
395. Then somewhere you did something wrong. But if you round that off, you still get 40. Okay? Right. Then they ask you to calculate the following table for the isotope that you get the most. Okay? They want the number of protons, they want the number of neutrons, and then they want the number of electrons. Now, first of all, you need to know which one you get the most. Ona, which one of those isotopes do you get the most? Do you find the most? Which one? The first one. How do you know it's the first one? Say again? All of them has protons. Look in your notes. Let her quickly look on your notes. How do you know? Yes, Carabello?
Ma'am, it has a higher percentage.
It's the highest percentage. If you look at all of the percentages, zinc 64 has 48.63%. That's the highest percentage. So it's the one that's the most abundant, the one that you find the most. 64. Okay, then Carabello, how many protons does it have? Not 64.
Ma'am?
Yes? I'm just commenting on everyone that is saying 64. It's not 64. 30, because the atomic number is 30. How many neutrons does it have, Sia? Don't say 64. 64 is the mass. That is. Mooi, hoe het jy gekom daar?
I took the, what do you call it,
64.
this minus the proton.
Yes, you get 34. And then how many electrons, Nyakano? 30. Where is your book? Let me see. Are you marking? Okay. Right, then we are back in your notes. We are busy looking at, or we looked at the different types of orbitals that we find. Alright, and the different shapes of them. We have spherical, we have pear-shaped orbitals. We say this is energy level 1, energy level 2, energy level 3, energy level 4. We have 1s orbital, then 2s, then 2p, 3s, 3p, 4s, and then just to break your brain a bit, 3d, and then a 4p. But don't worry about 3d this year just yet. All right. And we finished with, we spoke about the energy level diagram. So we can, instead of drawing circles and flowers and whatever, we can draw energy level diagrams, and that will help us to get the electron configuration with the Aufbau principle. Okay, now what is electron configuration again? I said, if you look at me, what do I consist of? What makes me me? I'm a lady, I have 2 children, I'm a teacher, I'm X years old, I am 1.6 meters, I weigh a certain amount. Okay, that is my configuration. That is what makes me me currently. Okay, so we can do that. We can find the electron configuration for each atom, and each ones will be different, and that is the way the electrons is arranged around the nucleus. Okay, so the energy level diagram or the Aufbau principle diagram looks like this. You don't have to show me all of that. Okay, you don't have to show that. You also don't have to show the nucleus. What you are going to draw is these circles with just those labels. Okay, we have now, I want you to, you have a small periodic table, or no, you have a big periodic table. Yes, I want you to have that open, close by. So on the previous page, so just have the pages open next to each other like this. All right, so what I want you to see is that we start with the 1s orbital there. Okay, so we start with the 1s orbital. Then we go to the 2s orbital, then the 2p orbitals, then the 3s orbital, 3p orbitals. Okay, so that's what I drew in here. I have 1s, 2s, 2p, 3s, 3p, 4s. You're only going to go up until 4s. Okay, now this is called the energy level diagram. So these circles all represent orbitals. We have 1s, 2s, 2p, 3s, 3p, 4s. Okay, so the 1, 2, 3, 4 represents the periods, the energy levels, and the S and the P represents the shape of the orbitals. Now, we're not going to draw in the different shapes now, but these should be like infinity type of orbitals. All right. Then the energy level here close to the nucleus, the energy level there is the lowest. And then the further away it goes from the nucleus, the more excited the electrons become, the higher the energy becomes. So the electrons here move much faster than the electrons there. Okay, are you with me? Right, now we're going to fill this in. We want to show where the electrons are situated, and we're going to do that with the help of the following on the next page. Okay, we have the following rules to help us fill this in. The Aufbau principle. First of all, the circles represent orbitals. Now, if you have extra classes somewhere else, or you use old textbooks or whatever, then some people use blocks instead of circles. So they will look like this. Obviously, you can see why I do not use blocks. And some people use lines to do that. Okay, instead of circles. I don't care which one you do. You can do any one, circles, blocks, lines, it doesn't matter. Okay, then the electrons occupy the lowest energy levels first. So you start from the 1s, and then you move up, 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 because they want to be the closest to the nucleus. Then, according to Pauli's principle, each orbital can occupy a maximum of 2 electrons. So in each circle, in each orbital, it can have 2 electrons, and they must have opposite spin. They spin in opposite directions. Okay. Now, you can either, like the picture that I have here, draw 2 arrows like that, or you can draw half arrows like that. You'll see I draw half arrows. Okay. Yes.
Then if you do the line thing, how will you know when it's Phsc?
What do you mean? Like that? Yes. Okay, then in any energy level, the s orbital must be filled before the p orbitals can receive an electron. We start with an s orbitals and then the p orbitals, and then Hund's rule says the following. Hund's rule, p orbitals in any energy level must each have 1 electron before they can receive a second electron. Okay, I'll show that to you in a moment. And then the maximum number of electrons in any energy level is 2n squared. Okay. But we will get to that in a moment. Alright, let's quickly look at an example. Nitrogen has what atomic number, Khali? Nitrogen atomic number what? 7. Okay, so it contains 7 electrons in its neutral atom. Okay, so here I drew the circles for you. Okay, you're going to start at the bottom, and the S, in the first energy level, there's only 1 orbital. It's that one. And it's going to have 1, 2 electrons. Sorry, 2 electrons. Now we're left with 5 electrons, because it had 7, we already filled in 2, 5 electrons. Then in the second energy level, we need to fill in the 5. Now, according to Hund's rule, you must, according to no one's rule, we must first fill in the s orbitals before we can fill in the p orbitals. Okay? So we're going to go 1, 2, 3, 4. And then according to Hund's rule, when we get to the p orbitals, each one must first have 1 before it can have 2. Okay, so we have 1, 2, 3, 4. We have 3 electrons left. We go 5, 6, 7. Okay, so that is the way the electrons are positioned, where you will find them. Now we want to draw the, I just want to make sure, we want to draw or write down the electron configuration. Okay, it's like a summary of what we just did. Rory, in the first s orbital, how many electrons do we have? Well, we can help her out. In the first s orbital, how many electrons do we have? In the first s orbital, how many electrons do I have? 2. So you're going to say 1s to the power of 2. Okay. In the second s orbital, how many electrons, Hope? 2. And in the second energy level, in the p orbitals, how many electrons start to? No. In all of them, 3. So that is called the electron configuration. Electron configuration. All right, now quickly go to the next page. Okay. This is going to be your homework. So you can see this is more or less the periodic table that I tried to fill in there for you. Okay, you are going to do this for not all of them, for the first 2 rows. You're going to do that. Not 2, 3. 3 periods, 3 rows. You're going to do that. I'm going to spot a few that I'm going to do with you. Yes. Same thing. 1, 2, 3 rows, 3 periods. Okay, let's look at hydrogen. Hydrogen has 1 electron. You will find it's all the way to the left, so it's in the s orbitals, and since it is in period 1, it will be 1s. If it's in period 2, then it will finish in the second s. Okay, right, so 1s, and it is a circle, and it has 1 electron. No difficult. Okay, let's go one down. Let's go to lithium. Lithium is in the second energy level, so you have to start at the first energy level, and then you can go to the second energy level. Okay, how many electrons does lithium have? It has 3 electrons. So you go 1, 2, 3. Okay, let's quickly look at boron. You must start at the first energy level. Then in the second energy level, we have the 2s orbital. And then boron is in the p block. You see that? Boron, number 5, is in the p block. So we're going to end with 2p, and there's 3 orbitals.
Why did you say number 4?
Because the rest that we're not going to do now, you'll do for homework. I just want to show you different atoms. Okay, so boron has 5 electrons. So we go 1, 2, 3, 4, 5.
So when it has electrons,
This electron will jump to there, and back, and back, and then. So if you drew in that electron there, it doesn't matter. If you drew it in there, it doesn't matter. Okay, let's look at neon, all the way here to the right. Neon. Okay, it's past the first energy level, then we have the second energy level, and it ends in the p orbitals. If you look, where's neon? It's all the way to the right, element number 10. Okay, so it has 10 electrons. So we go 1, 2, 3, 4, 5, 6, 7.
then what about D and F?
Just wait. 1, 2, 3, 4, 5, 6, 7. And then you fill in the rest. 8, 9, 10. We don't do the F and the D orbitals. You do a bit of D orbitals in grade 11, but that's it.
How many circles is D?
5. F7. Okay. Then I want you to go to sodium. No, sorry, not sodium. Let's go to phosphorus. Phosphorus is number 15. Phosphorus number 15. So we have 1s. If we look at phosphorus, it's in the third energy level, right? Number 15 in the third energy level. So we have to pass the 1s, and then the 2s. So write the 2s circle. Then the 2p. How many p orbitals are there? 3. So you make 3 circles. 1, 2, 3. Then we have the 3s. 1 circle. 3s. And then 3p. 1, 2, 3 circles. The S is 1. 3p is 3. So you have, there's phosphorus. So we have 1s, then you have 2s, 2p, 3s, 3p. Because it's in the third p orbital, you have to pass all of them to get there. Okay, so you have to draw all of those circles. Yes. Please? I want to, but we have to wait a minute. Otherwise the light bulb is going to burst. So, alright. So you start at the bottom. We go 1, 2. Then the second is orbital. 3, 4. Number 15. We're at number 15, Rory. Everyone has filled in except for you.
And when at 2p, when they say 1, 1, 1.
Say again.
At 2p, they're going to fill in 1, 1, 1.
And then 2, 2, 2. Okay, so we are at 4 electrons and we must get to 15. So now we're going to go to the p orbitals in the second energy level. So we are going to go 5, 6, 7, 8, 9, 10. We go 11, 12, 13, 14, 15. Where's your notes? Wow. Yours? But you have notes. Because you write on this. Khali, yours? Home. You have notes. Alright. Now, so you're going to do what we just said, you're going to do for the first 3 periods. So you're going to fill it in for all of them. Now something, yes.
If we, for phosphorus, for example, there are 3 s orbitals. So do we first fill in 1, 2, and then 3 s, and then we go to the 2p and 3p?
No. We went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Energy level 2 complete. Then you go to energy level 3.
And then why does the p orbitals only have 3 and the s orbitals only have 1?
That is the way they are. That's not. Remember, the orbitals they're not paths, right? It's not a blob that's there. That is the way the electrons actually move when they are there. For the s orbital, they just move there, but for the p orbitals, they move in different directions. All right. Now, what I want you to do or add to that is write down the electron configuration. So, if we look at the first one, it will be 1s1. For lithium, it will be 1s2, 2s1. Boron, 1s2, 2s2, 2p1.
Then when are we gonna write about this?
Didn't I just, when I asked him, do you have notes? What did I say? Ali? Must I phone your parents because I'm concerned about your short-term memory? No one in my entire school teaching career have ever asked me the same question so many times. Do we have homework? What homework? Do we have homework? What homework? Do we have homework? Okay, alright. Then if you look at neon, we have 1s2, 2s2, 2p6. Alright, now we spoke about neon, the noble gases being complete, being like perfect. Why are they perfect? Because the electrons are paired and the orbitals are filled. So it's almost like neon is like have you ever seen a typewriter?
Yes.
Ching! And then it goes on to the next one.
Yes.
Okay, so it's almost like this here is perfect, finish, klar, and then we go to the next one. Okay, so this electron configuration is that of a noble gas, which is perfect. So we can either write it like this, or you can write neon in square brackets like that. And these two things mean the same thing. They mean exactly the same thing. Okay, so yes.
For P, can I write them here?
Can I write?
Can I write those ones? Yes. For P, but they're not going to fit here.
You can, or you can do it in your writing book. But you can wherever you see it. All right. So if we need to write the electron configuration of P, you can do it in one of 2 ways. You can either do 1s2, 2s2, 2p6, 3s2, 3p3. Or, scientists are lazy but effective. That there is the electron configuration of what? It's the same as what?
3s.
The same as neon. We just did it. Up until there is exactly the same as neon. So instead of writing all of that, which is the same as neon, you can write in square brackets neon and then 3s2, 3p3. Which is easier, shorter. Okay, but you can write anyone. It won't matter. Right, so that, ladies and gents, will be your homework to complete this page. 3p3, yes, because in the third p orbital there's 1, 2, 3 electrons. Yeah, to complete this. That, not this. We will do that together in class. Alright. Then we are going to go to ions. Ions. Now, you had to memorize ions, the anions and the cations, and I spoke about what is an ion. Okay? So I'm going to read and then explain again. Shh. The elements in a group have the same number of electrons in the outer energy level, in the valence energy level. It's the same thing. So if we look at, quickly, you don't have to page back, I'll page back. If you look at hydrogen and lithium, hydrogen has in its last energy level 1 valence electron. Lithium in its last energy level has 1 valence electron. So all of them in the same group have the same number of valence electrons. Okay, so that is what it says at the top. Same group, in the same group, have the same number of valence electrons. These electrons are called valence electrons, and it's related to the group number. So if we look there at beryllium, magnesium, calcium, they are all in group 2. They all have, so they're in group 2 and they all have 2 valence electrons. If we look at oxygen, sulfur and beryllium, okay, look there, they are all in group. Oxygen, sulfur, group? No, it's group 16. So how many valence electrons will they have? No, that's their valency. How many valence electrons does oxygen have? No, that's the valency. Same question. There's oxygen. 1, 2, 3, 4, 5, 6. In group 16, it has 6 valence electrons. Okay, so it has 6 valence electrons. Okay, now how do ions form? Ions are formed when a neutral atom gains or loses electrons. And this is where my story comes in about the upper class, middle class, lower class, and they will lie and cheat and steal electrons. You remember that? You remember? Miracle. Okay. Right. Now, metals tend to lose their valence electrons. They tend to give away the outermost electrons to form positive ions or cations with a charge equal to the group number. So if you look at sodium, it becomes, sodium is in group 1, so it will lose 1 electron. Okay, so it will now have 11 protons and 10 electrons. If you look at calcium, it's in group 2, so it will lose 2 electrons. Calcium originally had 20 electrons and protons. It loses 2. How many electrons will it have now? 18. Aluminium is in group 13. It will lose 3 electrons. How many protons does the aluminium have? 13. And if it gives away 3 electrons, how many electrons will it have? 10. Okay. Then non-metals tend to gain electrons to fill the outer energy levels. And they form negative ions called anions. Anions. Okay, so I told you there's different ways to determine this valency. If we look at nitrogen, nitrogen is in group 15. Group 15, so it will gain 1, 2, 3 electrons to become like neon. So it has 7 protons, and if it gains 3 electrons, it has 10 electrons. Phosphorus, also in group 15, it has 15 protons. If it gains 3 electrons, how many will it have? 18. 18. If you look at sulfur there, sulfur is in group 16. And it has, in group 16 and element 16. And so it has 16 protons. It will gain how many? 1, 2 to become like argon. So how many electrons will it have? 18. Chlorine is in group 17. It has 17 protons. And it will gain 1 electron. So it will have 18 electrons. Okay. And then lastly there, noble gases do not lose or gain electrons at all. Okay, so they don't lose or gain because they are perfect and therefore they are chemically unreactive. Chemically unreactive. Okay, now grade 10s, your homework. On top of this, your homework will also be to complete, you remember we didn't complete this table? To complete this table, okay, I'm going to go through it with you in a moment. And then also to do number 6 there. And then also, not done yet, in this booklet, I know you have homework in this booklet that we haven't marked yet. We will do that tomorrow. Yes, about the boiling point and so forth. So on page on page 52, I want you to do activity 10.1, the whole activity. Yes. Okay, I'm not going to give you the other activities, but you can do it and ask me if you are right or wrong. Alright, so you have lots of work. I want to do with you together quickly this, thank you. Shh. I want you, are you going to listen and then I'll give you time to do it in class? So, alright, I want to quickly do with you this table. We'll do this whole thing together. Hopefully we will finish and then you have a little less homework. Okay, so you can do it on the page. Let's look at the magnesium ion. Okay, magnesium symbol, Chlorine is what? Magnesium symbol. Mg. Alright. Mg. Now, what's the mass chlorine of magnesium? Look on your periodic table, in your notes. And its atomic number? 12. Alright, now chlorine, keep that open. They say magnesium ion. Right? Magnesium ion, will it lose or gain electrons? Gain. And how many will it lose? 2. So does it become 2 plus or 2 minus? 2 plus. So our notation is not finished. It's going to be magnesium 2 plus. Alright. So, Akamu, how many protons does it have? 12. And how many neutrons? And how many electrons? It originally had 12, but now it became the ion. So how many does it have now? Chlorine, did magnesium lose or gain electrons? So will it have 14 electrons? It has 10 electrons. Okay, let's look at the fluoride ion. Wow. Fluoride's symbol? Sorry? Just an F. And the mass is? And the atomic number is? Okay, but when they said the fluoride ion, it means it lost or it gained electrons. What will it do? Lose or gain? Fluorine.
Then it's 9 protons.
It will gain. How many will it gain? Fluorine, 9 electrons. If fluorine gains 9 electrons, it goes this fluorine. It goes 1, 2, 3, 4, 5, 6, 7, 8, 9 in the organs. It will gain 1 electron. Okay, so fluoride ion is just with a negative because it gained 1 electron. Okay, so let's see. How many protons does it have? 9. How many neutrons? How did you get to 10? More. And then how many electrons will it have? Nia and shh. No, don't listen. I just said Nia. So it had 9 electrons. And then Muha, what did happen here? It gained? Did it lose? It's 10. Because it had 9 electrons and then it gained 1.
But then when it's 2 plus,
It means it lost 2.
positive.
So if it's negative, you
So if it's negative, you add. If it's positive, you subtract. Okay. Relo, next one, they only give you this and this. Which element are we busy with? Calcium. Okay, but also, Relo, you can see, element focus. The number of protons and electrons differ. So it means it's calcium ion. All right. So what's all? Calcium symbol? Ca. How many? What's the mass? Sorry. And the atomic number? 20. And it says, Relo said we are busy with an ion. Calcium, will it lose or gain electrons? How many will it lose? 2. How do you know it's 2? How do you know it's going to lose 2? Okay, that's good that you saw that, yes. But also, if you look on the periodic table, it's in group 2. Do you see that? Group 2. So it becomes plus 2. So it means it loses 2 electrons. 2 plus. All right. Courtney, how many neutrons does it have?
Then it has 20.
How did you get to 20?
40 minus
Wait. All right. Next one, again, they only give you numbers. Tepo, with which element are we busy with? Say again? Did you answer? No, Chlorny answered for you. Is it a question or an answer? No, I don't want an answer. Thank you. 13 protons. Tepo? Say again? Aluminium. Aluminium. But, Tepo, can you see the number of protons and electrons differ? So it's not just aluminium, it's aluminium ion. Yes.
So then, like, since like you weren't able to see the answer, is it fine if you say like, isn't it? Then you say the answer.
Dando, what is the symbol for aluminium? Al. What's the mass? No, that's the atomic number. What's the mass? 27. Alright, and then, Akutlano, what is the number of neutrons for aluminium? How did you get to 14? Right. Then the last one at the bottom, 17 and then 18. Retabile, which element are we busy with? What are you checking? And what's the L's name? Okay, chloride or chlorine? It's a chloride ion. Ion because the number of protons and electrons differ. Symbol for chlorine or not? Symbol for chlorine? And the mass? Okay, so if you say now 35.5, that will be all right. In a test or an exam, I'll tell you it's the chloride, let's say 35 ion or whatever. Not 30, yeah, 35. Okay, because you can't get a half a neutron. Okay, so for today, let's make it chloride 35. And the atomic number, Orna? And does it have a valency? And what will the valency be? -1, because it has one more electron than protons. And then for this specific isotope, Carabello, how many neutrons will it have? Don't say 16. 18. All right. So you know what your homework? You can. I think it will be good if you do number 6 now here. Yes, we can. All right. So if they say the natural boron contains so much of boron 10 and so much of boron 11, give the electron configuration for a boron atom. Carabello? Boron. You asked if we can do it together, me and you. Here we go. Carabello, boron is in which energy level does it end? 2. So we have, so this is question 1, we have 1s, 2s, and then 2p. Yes. You guys like to copy each other's homework, don't you? Carabello, how many electrons does boron have? 5. 1, 2, 3, 4, 5. Carabello, you need to check your glasses. If you squint, wearing glasses too there.
I was like trying to make sure because
Yeah. Alright, but that's not what they want. They didn't ask for the energy level diagram or the Alf power diagram. They asked the electron configuration. So from there, what would the electron configuration be, Sia? 2p1. All right. Can you see something here? If I give you just this, let's say I give you this. Right. Can you tell me which element do we have there? Yes. How do you know that? Yeah? Because? Huh? Yes, okay.
That means 5 is going to be your 17th row because your 18th row is 6.
Okay, so, okay, good. So you check the valence electron configuration. Valence electron configuration, you see, is at energy level 2, so you check we're in energy level 2. Then you see in the last energy level, the valence energy level, we have 7 valence electrons. So it means it's in group 17, so that is chlorine. They can ask you that in a test or an exam. That's why I asked this question now. Did you write it down? Alright, you guys know what your homework is?
Ma'am,
Yes.
I did my number 2 years. I will write it in the book.
Or just do your boo here, your B here.
Okay.
Tot ziens jullie. Lekker dag. I'm waiting for you guys to leave my class so that I can drink coffee.
Ja,